There are relatively easy tests to determine whether a given number is divisible by any of the integers 2 through 10. You may wonder why it matters, given that everyone always has a calculator available. But being able to quickly decide without a calculator is often quite useful. A short list of example uses is given here. In factoring numbers, finding factors or divisors quickly is very convenient. In reducing fractions, it's helpful to quickly notice when a numerator and denominator have a common factor. In determining whether a given number is prime, it is enough to check the number for divisibility by primes up to its square root. Let's start with the divisibility rules for 2, 4, and 8. An integer is divisible by 2 provided the last digit is divisible by 2. In other words, an integer is divisible by 2 provided the number is even. You probably already knew this one. An integer is divisible by 4 provided the last 2 digits represent a number divisible by 4. An integer is divisible by 8 provided the last 3 digits represent a number that is divisible by 8. Notice how the numbers 2, 4, and 8 are all powers of 2, and the number of digits involved in the rule is the same as the power of 2. Let's consider some examples to illustrate. The number 345,964 is divisible by 4 since 64 is divisible by 4. The number 1,546 is not divisible by 4 because the number represented by the last 2 digits, 46, is not divisible by 4. The number 21,864 is divisible by 8 because the number represented by the last 3 digits, 864, is divisible by 8. Note that 864 is 8 times 108. The number 32,108 is not divisible by 8 since 108 is not divisible by 8. Of course, the number 32,108 is divisible by 4. Now let's consider the divisibility rules for 3 and 3 squared. These rules are completely different from those for the powers of 2. An integer is divisible by 3 provided the sum of its digits is divisible by 3. An integer is divisible by 9 provided the sum of its digits is divisible by 9. Again, let's look at a few examples for illustration. The number 46,932 is divisible by 3 since its digits sum to 24, and 24 is divisible by 3. The number 1,546 is not divisible by 3 since its digits sum to 16, and 16 is not divisible by 3. The number 32,877 is divisible by 9 since its digits sum to 27, and 27 is divisible by 9. Note that any number divisible by 9 will also be divisible by 3. The number 32,108 is not divisible by 9 since its digits sum to 14, and 14 is not divisible by 9. Now we'll consider divisibility by 5, 10, and 6. We include the rules for 5 and 10 for the sake of completeness, since most people will already be familiar with these. An integer is divisible by 5 provided the last digit is divisible by 5. In other words, an integer is divisible by 5 provided it ends in 0 or 5. An integer is divisible by 10 provided it is divisible by 2 and by 5. Note that 10 is a product of the primes 2 and 5. To be divisible by 10, a number must be even and end in 0 or 5. Therefore, it must end in 0. The rule for divisibility by 6 is similar to the rule for 10. An integer is divisible by 6 provided it is divisible by both 2 and 3. Thus, the number must be even and its digits must sum to a multiple of 3. A few examples will be useful. The number 46,932 is divisible by 6 because it is even and the digits sum to 24. 1,546 is not divisible by 6 because the digits sum to 16, which is not a multiple of 3. $32,877 is not divisible by 6 because it is not even. Finally, just for fun, let's consider the rule for divisibility by 7. An integer is divisible by 7 provided the number produced by deleting the unit digit and subtracting twice the deleted digit from the remaining number is divisible by 7. Let's look at a few examples, although this rule isn't all that practical to use. In practice, we would just divide the number by 7 and see if we get an integer quotient. 112 is divisible by 7. To see this, we take 112, delete the 2, this produces 11. Now we subtract twice 2 from 11. We get 11 minus 4, which equals 7, a number that is clearly divisible by 7. Therefore, our original number, 112, is divisible by 7. For a second example, let's consider 1001. 1001 is divisible by 7. Let's apply the rule to verify. Start with 1001. Delete 1 to produce 100. Now subtract 2 times 1 from 100. We get 98, which is 2 times 49, and is divisible by 7. Therefore, the original number, 1001, is also divisible by 7. Let's consider one final example. 157 is not divisible by 7. To see this, start with 157, delete the 7 to produce 15. Now subtract 2 times 7 from 15. 15 minus 14 equals 1, which is not divisible by 7. Therefore, the original number, 157, is not divisible by 7. Here is a summary of the divisibility rules we've discussed. Notice that the prime numbers 2, 3, 5, and 7 have completely different rules. Powers of primes have rules similar to those of the base prime. And finally, divisibility by a product of two distinct primes requires divisibility by both of the primes.